This video will introduce you to exponential functions. An exponential function is any function that can be written as y equals a times b to the x, where a is not equal to 0, b is greater than 0, and b does not equal 1. So here's some examples. We've already seen exponential functions that look like this. Y equals 1000 times 1 plus 0.05 to the x, and this is an exponential function for compound interest growth. But they don't have to be just for compound interest. We can have functions like this: y equals 7 times 8 to the x, or y equals 4 times 1/2 to the x. All of these are examples of exponential functions. Now, given a table, here's how you tell whether the table represents an exponential function. First, you can look at the x column and see that they each go up by 1. When that happens, when they each go up by 1, then you can look at the y column, and you use a hockey stick configuration, but you want to look at ratios now. So we're going to divide 6 by 3, and we get 2. Here, we divide 12 by 6 and get 2. Here, we divide 24 by 12 and get 2. And here, we divide 48 by 24 and we get 2. So this is an example of an exponential function, and you can see that because all of these ratios in the y column are the same. The ratio is the base of the exponent, and this value over here, where y equals 3 when x equals 0, that one represents this coefficient. Now let's take a look at the second one. Once again, the x's go up by 1, so we can look at the y's. And now we divide 54 by 162, and we'll get 1/3. If we divide 18 by 54, we get 1/3. 6 divided by 18 is 1/3, and 2 divided by 6 is 1/3. So once again, the 1/3 is the base of the exponent, and this value here, 162, when x is 0, that is the coefficient of y of the exponential term. Here's how you evaluate an exponential function. We'll take f of x equal 4 times 1/3 to the x, and we'll evaluate this for 3, for x equals 3. So first, as always, we plug 3 in. So this will be 4 times 1/3 to the third. And this will be 4 times 1 over 3 cubed, or 4 over 27. Next, we evaluate the function 6 times 4 to the x. And this will be 6 times, well, 4 to the x happens to be 1024. And 1024 times 6 is 6144. So that's how that function evaluates. Finally, we'll look at graphing exponential functions. And the principle behind graphing exponential functions is exactly the same as it is with any other function. You pick a couple of points and graph them. Now, it's helpful before we start to look at what the graphs of exponential functions look like. So let's take a look at one. What you see here on the inset is f of x equals 2 to the x. And the general shape of that is as you see. Now, if there's a negative sign in front of the 2, in other words, we have g of x equals negative 2 to the x. And that's not negative 2 to the x, that's the opposite of 2 to the x, this function will look like this. If the base being raised to a power is a fraction, then the function is a decreasing function that looks like this. This is h of x equals 1/2 to the x. And then if we put a negative sign in front of that, we would get a function that looks like this. Q of x equals negative 1/2 to the x. So now that we've seen a couple, we know what this should look like. So let's graph some points. One of the easiest points to graph is when x is 0, because 2 to the 0 equals 1, so this will equal 3. So we can put that graph on, that point on the graph, and we see that that's actually the y-intercept. Now let's go backwards. When x is negative 1, this is 2 to the negative 1, that's 1/2 times 3 is 3/2. And when x is negative 2, this will be 2 to the negative 2, that's 1/4 times 3 is 3/4. So let's graph those 2 points. That'll be negative 2, 3/4, and negative 1, 3/2. Now let's go to the positive side. We have x equals 1, so y equals 3 times 2 is 6. X equals 2, so y equals 3 times 2 squared, that's 3 times 4 is 12. And when x equals 3, this is 3 times 2 to the third, 3 times 8, which is 24. And let's put as many of those points on the graph as we can. Here's the point 1, 6, 2, 12, and the next point doesn't really fit. So to draw the graph roughly, it would look like this. We'd start off the graph through here, 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 and then the graph will go off in that direction. And of course, if you drew this graph carefully, that line would be much smoother. This is the best I could do by hand, but you get the idea.